everybody.
Everyone.
And here we are. This time we're reporting live from 181.
Yes, very exotic.
Yes. Live? I don't know if we're really live.
You're not
if they're
live at all.
watching. I mean,
No.
we're live right now.
Yeah, but it's pre-recorded.
Yes. Okay, anyway, carry on. All right, so last night you worked with some formulas and how to figure out ionic formulas.
Fun.
Yes. Let's flash back a little just as a reminder. A ionic bond is between...
Metal and a non-metal.
Right, where one gives electrons and the other one gets electrons.
Yes,
Do you
give and
remember-
take.
Yes. Do you remember which one would give electrons?
Let's see. Okay, so the metal will give its negative electron, meaning it will become positive.
Right.
It's losing negatives.
Yes. And then the non-metal will gain the electron, so it will become negative.
Yes, exactly.
Okay, perfect. So we're going to take this one step further, as always. And today we're going to look at those crazy little fellas right in the middle.
Cause so many problems.
I know, they do. But hopefully it'll be simple with that. And then we also are going to talk some polyatomics. And that's a fancy word for a very simple thing.
All right.
All right, so here we go. The transition metals, we all know, are groups 3 through 12. What's kind of crazy about the groups 3 through 12 is, unlike the other groups where they have, in group 1 I have 1 valence electron. Group 2 I have 2 valence electrons. These guys right here in the middle kind of can, mix up. I know, it's crazy, right?
Horrible.
So they can have more than one type of ion.
Got it.
Okay. Now, most of these, there's a table, you can just look them up. Okay. So when you're making the formulas, it normally will give you what charge it is.
So if I have the formula, it will pretty much tell me the charge.
Exactly.
Okay.
Yes. So what we're going to do here is we're going to practice just kind of going through the ones that have a different charge.
Okay.
But same process as before. We still got to get those charges to add to 0. But now, instead of iron always being a +2, it could also be a +3.
No.
Some of them, if you look, lead sometimes is a +4, which is not on here, which is interesting, but it can be. So we're going to go through a couple of these practice ones.
Sounds like fun.
Yeah. Okay, so how do you know which one to use is the question. Everyone's like, well, how do I know?
There's 2 of them. What do I
Exactly.
do? Which one's this one? Yeah.
Right. So, in the case of when they give you the name, they will write it with a Roman numeral indicating what is the charge.
Okay.
So, for example, copper 1, well, that's copper and has a +1 charge.
Oh, copper 1 has 1 charge.
Exactly.
And let me guess, iron 2?
Is a 2.
2 charge.
I know, it's very, very
Okay.
non-trickery.
Yeah, non-trickery.
Non-trickery, I'm sure
Trickerless.
that's what yes. So the same thing over there, copper 2, it's +2.
Yeah.
And
okay.
iron 3 is going to be
3.
Yeah.
So the hardest thing is knowing your Roman numerals up to like 5.
Exactly.
Okay.
Yeah. Okay. So, for example, if we look at the bottom, it says try these. We have iron 2 and chlorine.
Okay.
So we automatically know, since it's iron 2, that it's got a +2 charge.
Yes.
Okay. And then chlorine has a -1 charge.
Okay.
Okay. So again, we want to make those add up to 0. So in order to add up to 0, we're going to need 2 chlorines.
Okay, because +2, I would need a -2. Okay. Yep.
So we would be FeCl2.
Oh, okay.
Okay.
Not too
Pretty
bad.
simple. Yeah. So here's a few. We have silver 2 and sulfur.
Fun.
Okay, so silver 2 is a
2 charge.
yeah, and sulfur is in group 16, which is a
2 charge.
so all we would do is write Ag.
S.
Pretty simple.
Love it.
Okay, so take a few seconds, try those out on your own. All right, good luck. We'll see those in class. All right, now we move to the infamous polyatomics.
Ooh, many atoms.
Exactly. Okay, poly meaning many, atomic meaning
Atoms. Just
right.
like that, yeah.
So when you put them together, it means
many atoms
together.
together.
All right.
Because you
So-
put them together. I got
Yes,
there. You go.
exactly. So these are always going to be on a chart. You're not going to have to memorize any of these.
No.
It'll be, here's a chart, look it up, write it down.
Yeah.
Super simple.
Very easy.
Yeah.
Yeah.
Some of the examples or the most common ones we'll probably be using is hydroxide, which is OH. So these polyatomics are always going to have capital letters together. So that's how you know that it's a polyatomic. And
Okay.
there's multiple capital letters together.
When I have more than one element in a compound, or more than 2 elements in a compound, there has to be a polyatomic in there.
Exactly.
Okay.
Yes. Carbonate, for example, CO3 is a -2 charge. Again, all you're going to do is look it up on the chart, tell you what charge it is, and,
It sounds complicated, but I feel like it's really, really simple.
it is really simple.
Let's take a look.
All right. So here's an example, Na and CO3. So we're going to put those together. Well, sodium's in group 1, so it's
1 charge.
exactly. Carbonate, I looked up on my table.
So I looked up CO3, and it said carbonate, and it said it had a 2 charge.
Exactly.
So I did not have to know anything.
You don't have to know
Okay.
anything. Okay? And it's a -2. So again, we have to make those equal 0. So in order to do that, I'm going to need 2 sodiums.
Gotcha.
So whenever I need to add another, or not add another, have a multiple of 1, we need to do the little subscript. Sub
Gotcha.
meaning below.
Below the script. Subscript. So I have Na2CO3. Got it.
Yes. Okay. Now, one other little thing that's a little tricky. If I ever have to duplicate or have more than one polyatomic, I need to put it in parentheses.
Well, that kind of makes sense, right?
Yes.
Because in this example down here, you can't have 3 SO4s because it would look like SO43.
Right.
You'd have to put it in parentheses.
And that would completely change the...
Did not the same as SO43.
No, definitely not.
No.
So in this case, aluminum, group 13, so it's a plus 3.
Trace.
Sulfate, again, chart 2,
Boom.
done.
Sulfate.
Real easy.
Yeah.
Okay. Now, whenever I have a 3 and a 2, these are a little tricky, but really you're just looking for a multiple. Okay, so I know that I need 2 of the plus 3s. Okay, because 3 times 2 is a positive 6. And then negative 2 times 3 is going to be a negative 6. So
okay.
plus 6 minus 6,
Done.
0.
There you go.
Okay, so I would write Al2. Now, I need a multiple of a polyatomic, so I need to put my SO4 in parentheses.
Got it. So
Put the little 3 on the outside.
clearly says I have 3 SO4s,
Right.
not SO43.
Exactly.
Okay.
Okay, so let's try a few. All right, you're going to give these a whirl. Again, remember, if it's polyatomic, which all those on the right-hand side are, and a majority of our polyatomics are anions, so most of them are going to be negative.
And I know they're polyatomics because there's more than one capital letter.
Exactly.
Right? Okay.
So look those up, give them a try, and we'll go over them in class. See
Bye.
ya.